Alright, I'm right here at the end of my final run, and I'm just approaching that point where it looks like it's going to change. So I'm going to add in a drop or two more and see if we can get that very, very clear change on the video. Put in 2 drops there. I'll go 1 more drop just to make sure that you can see it. I can see it pretty clearly, but it's my understanding that it doesn't show up as well on the video. I'll get a piece of white paper to put behind here and see if we can see that on the video. So there we go. Again, when we're doing this in the lab, in person, that pink needs to be a very, very subtle pink, but it does have to persist. It has to stay there for a while. It can't just show up and then go away when we swirl it. So I've taken all of my readings and entered them in here. I've left the bottom line blank so that you can do the calculations. It's a very, very simple calculation, just like we did over in our recommended practice trial. And so the milliliters of sodium hydroxide used for each trial is what we're going to use then for our analysis. So for whatever you get here in this box, we're going to use that for our trial 1 calculation for the number of moles of sodium hydroxide used. And it's a very, very straightforward calculation. That number of milliliters times the fact that 1 liter is the same as 1,000 milliliters. I'm going to orient it with the liters on top so that the milliliters cancel. And the concentration of the sodium hydroxide we were using was 0.1044 moles per liter. That's going to cancel out liters, and then I'm left with an answer in moles of sodium hydroxide. The next step, after you've done each of those calculations, is to write a balanced equation for this reaction. And remember, the reactants that we're using are sodium hydroxide, NaOH, and hydrochloric acid, HCl. So put those 2 things together and see what you might get for products. The next step says calculate the moles of HCl used in each trial. Well, basically what we're going to do is we're going to use that molar relationship from the balanced equation in number 2. So you have some number of moles of sodium hydroxide for trial 1 that you calculated in problem 1. And then we're going to use that molar ratio from problem 2 to get the number of moles of HCl. Now, because you're essentially multiplying by 1, the number isn't going to change, but what happens here is your dimensional analysis starts to go to play, so that we've changed the number of moles of sodium hydroxide to the number of moles of HCl. And finally, for number 4, we're going to calculate the molarity, remember that's moles per liter, of HCl. So in the previous problem, you just calculated some number of moles of HCl. And remember that that's the number of moles that occurred in 10.00 milliliters. I have written there 10, but if we want to be very exact, it's actually 10.00 milliliters. And again, we use that equilibration statement of 1,000 milliliters for each 1 liter. And that gives us some number of moles of HCl for each liter, which is, of course, molarity. Okay, good luck.